In previous video, we have looked at how to balance a redox equation using ion-electron method in acidic medium. In this video, we are going to continue the concept of the previous video on how to balance a redox equation using ion-electron method but in basic medium. The learning objective that I'm going to cover in this video is write and balance redox equation by ion-electron method, mainly in basic medium. We have seen how to balance a redox equations in acidic solutions. Now we move on to look at how to balance a redox equation in basic solution. So basically, to balance a redox equation in basic solution, is still following the 5 steps, but you have an extra step, step number 6, whereby you need to add same number of hydroxide ions with hydrogen ion on both sides of the balanced redox equation. To show how to balance a redox equations in a basic solution, I'm going to use the same example as the redox equations in acidic solutions. So just to recap a bit, so before we start on the first step, we need to separate the redox equation according to the species. So like permanganate ion consists of manganese, and also the manganese 2+ ion consists of manganese, so this will be a pair. And for the oxalate ion consists of carbon, and also carbon dioxide consists of carbon, so this should be another pair. Since I'm using the same examples as in my previous video on how to balance a redox equation in acidic solution, so for the next part of this video, the first 5 steps, I'm going to go through very fast. If you have problems to understand these 5 steps, it is highly recommended for you to watch back my previous video. After we have separated the redox equations according to their species, then we can start with step number 1, balance atoms other than hydrogen and oxygen. Step number 2, balance oxygen using water. Step number 3, balance hydrogen using hydrogen ion. And in step number 4, balance the charge using electron. So in step number 5, we multiply each half reactions with an appropriate integer to equate the number of electrons. Then we sum up both half equations together to give us overall redox equation in acidic medium. To balance a redox equations in basic medium, we need to add in step number 6. After step number 5, we get 16 moles of hydrogen ion on the reactant side. In step number 6, to balance the redox equations in basic solution, we need to add in equal number of hydroxide ion with hydrogen ion on both sides of the balanced redox equation. So means that we need to add in 16 moles of hydroxide ion both on the reactants and also the product sides. And must remember, 1 mole of hydrogen ion plus 1 mole of hydroxide ion giving you 1 mole of water. So on the reactant side, now we have 16 mole of hydroxide ion and also 16 mole of hydrogen ion. So this will give us 16 moles of water. So now can you see that water appear on both reactants and the product side? On the reactant side, 16 moles of water, and on the product side, 8 moles of water. So means that here we can cancel out water to give us 8 moles of water remains on the reactant side. And this then will give us overall redox equation in basic solutions. You might want to pause this video for a while to try test yourself too. For more reading, you may refer to the Brown's book, page 128 to 131, and also page 896 to 900.